Hello and welcome back to Mr. Farina's Algebra 1 class. Today we're going to be focusing on section 9.8, which is factoring polynomials completely. Now, this is no different than everything we've been doing. All we're doing is taking everything and putting it together. Now, when factoring polynomials completely, the first step that we do is we look to see if there's a greatest common factor. And if possible, we'll factor out that greatest common factor. So we'd have the greatest common factor times some remaining polynomial. Now, once we're done factoring out the greatest common factor, all we do is we look to see if the remaining polynomial can be factored. And if it can, you always have to remember that we're going to factor it out, and then we'd have, the GCF times the factored version of the remaining polynomial. Okay. Looking at some examples down below, they start off pretty basic, and then as the days go on and we practice over and over and over, they will get a little more difficult. Looking at the first example here, if I look at these three terms, 3x squared minus 6x minus 45, I notice 3, 6, and 45, the largest number of the GCF that can go into it is 3. Now, when I factor out this greatest common factor of 3, I'm left with x squared minus 2x minus 15. Now, when I look at this remaining polynomial, I have to ask myself, 1, is it factorable? 2, what type of factoring problem does it give me? Well, looking at it, I know I'm going to be looking for numbers that multiply to give me negative 15 and add to give me negative 2. Well, what numbers satisfy both of these? Well, that number would be negative 5 times 3. Those factors would be negative 5 times 3, and those also add up to negative 2. So, how does this remaining polynomial factor out to be? Well, that would be x minus 5 times x plus 3. But when we go to write our final answer, we can't forget about this greatest common factor. So, our final answer here is 3 times the quantity x minus 5 times the quantity x plus 3. It is very, very important to make sure you bring down that GCF in your final answer. Now, looking at the second one, this is a tad bit more challenging. Now, looking at 12x to the third, 21x squared, and negative 45x. Looking at the numbers, I know when I go to get my GCF, the largest number that goes into 12, 21, and 45 is 3. But I also have to recognize that each term has an x, and I can always pull out the term, the variable expression with the smallest exponent, so that would be x. So my GCF for this problem is 3x. Now, once I factor out that greatest common factor, I end up with 4x to the second plus 7x minus 15. Now, I have to look, is this factorable? And if so, what method would I use? Well, looking at this, it's a quadratic trinomial, and in this quadratic trinomial, I have a number in front of x squared, which automatically tells me I'm going to have to use the AC method. Now, with these problems, because there's a lot of work involved, I like to copy and paste them down below. And I like to factor it out and away from the problem. Now, what numbers, if I multiply A and C, I get AC is equal to negative 60, and my B is 7. Well, what numbers multiply to give me negative 60 and add up to 7? Well, looking at that, I would say, let's see, 12 times negative 5, because 12 plus negative 5 adds up to 7. So, remember, I'm going to break that bx term up into 12x and 5x and rewrite the problem as 4x squared plus 12x, and excuse me, that's minus minus 5x minus 15. Then I group the first two terms, the last two terms. Here I'm actually going to factor out the 4x. When I factor out that 4x, I'll end up having x plus 3 left over. Because this is negative 5x, I'm going to factor out a negative, and then I look, 5 and 15, common factor is 5, and when I divide both of those by 5, or negative 5, I get x plus 3. Well, now it just becomes a grouping problem. So what's on my insides? X plus 3, and my outsides go in another set of parentheses to give me 4x minus 5. So it's kind of like, if you think about it, if you go to the grocery store and the lady at the register says you owe her 4x squared plus 7x minus $15, it's no different if she told you owed her x plus 3 times 4x minus $5. These are the same expression written differently. But going back to our final answer up here, once we completely factor this, we have to bring down the GCF and then write our factored form of the remaining polynomial, which was x plus 3 times 4x minus 5. And here is your final answer. If I go ahead and remultiply this all out, I should end up with the same exact answer as I had before, or what I started with in terms of this polynomial. Now the last problem, okay, if I look at the greatest common factor here, what is the largest number that goes into 20 and 45? Obviously that is 5. Now, do both terms have an x? No, so I cannot factor out an x, but both terms do have a y, so my greatest common factor is 5y. Now, when I divide both of these by 5y, I'm left with 4x squared minus 9. Anytime I have a polynomial, if I look at this remaining polynomial now, anytime I have a polynomial with two terms linked by subtraction and subtraction only, I'm basically going to see, can I use the difference of two squares? Well, if I were to take the square root of 4x squared, would it come out nice? Yes. If I take the square root of 9, does it come out nice? Yes. This problem here is a difference of two perfect squares. So remember, when we factor this type of problem, all we do is we add the square roots, then we subtract the square roots. But if we go to write our final answer, we must include our GCF. So this polynomial 20x squared y minus 45y factors completely out to be 5y times 2x plus 3 times 2x minus 3. It is your job now to take what we learned here and apply it to the practice problems. Thank you very much and have a good night.